All right, let's go ahead and get things started. So a couple things before we really, kick things off. This is actually going to be the last class for this semester. We're gonna start back up at the, in the next year. But for now, this right here is going to be the final time that we're going to meet for at least like 2-3 weeks. Now, what we're gonna do here today is we're gonna try to get through as much of the remaining part of this chapter as we can. I know it's gonna be a lot. I honestly don't think we can really get through all of it, but we'll get through what we can, and then after the break, we'll come back and we'll finish things up here. But yeah, so let's just go ahead and get things started here. So, bit of review before we really jump into it. Last time we talked about expressions, and we talked about what to do with expressions, right? We found out that if you have, two things and that are equal to each other, that's actually just two expressions that have an equal sign in the middle, right? And what we said was there's a couple things that you can do. First things first, if you replace something with something that is equal to it, that doesn't matter, right? You can always make any replacements as long as it is always the same, right? As long as it's still the same thing. So like if I have x plus x, I can replace this with 2x however I want. I don't need to keep it as x plus x. I can change it to something else that is the exact same thing. But as soon as I do something that changes the value, right? As soon as I either add a number or subtract a number or multiply or divide or anything like that, as soon as I change the value that's there, I need to do it to both sides, right? We said that, yeah, you can add stuff to it. You can add 2. You can, multiply by 2. But if you do that, you got to do it to both sides, right? If you don't do it to both sides, it's no longer the same thing, right? Like just think about it, right? If I have, 3 equals 3, if I add 2 to one side, now it's 5 equals 3. That's not true anymore, right? So you got to do it to the right side too. You got to make this 5 equals 5. You got to add 2 to both sides, right? So this is the way that you're going to see it a lot in school. You may also have seen it as, okay, if this side over here is, let's say, for example, you have x plus 2 equals 3, right? If some places you may see it as, hey, let's move this 2 to the other side. And when you do that, it becomes negative. You may see it that way. But what we're going to show here is we're going to show it the way that we want to do it here, which is saying, okay, we want to get rid of this 2. We want to get x alone. The goal is always to get x here alone on one side. We want it to only be on one of the two sides. We want it to be alone. Nothing else needs to be here. So that means we need to get rid of this 2. To get rid of this 2, we need to remove it, right? It's currently being added. So to remove it, we got to undo. Undoing, there's a really important reason why I say undo. We're going to talk about that in the next section. But in order to undo addition, you got to subtract. So you subtract 2. And since you subtract the 2 from the left side, you got to do it to the right side too. So you subtract 2 here, you get x equals 1. So this idea is what we're going to be using for the next couple problems. And that's what you guys are going to be doing here. So let's go ahead and jump right on into it with problems 5.9 through 5.11. So problem 5.9, part A. Let's go ahead and have let's go ahead and have Joshua start us off today. Joshua?
Yes.
This problem right here.
Okay, give me a sec.
Yeah, just when you're going through this, right, I just want you to kind of talk out loud. Just let me know what steps you do so I can write it out down so that everyone's able to follow along, right? If you just, do it on your own.
Simple.
Mhm.
Add the difference and the subtractor.
So what do you mean by that?
Add 4 and 2/3 and 2 and 4/5 together. That's how you
Okay,
do
so you're saying we gotta add 4 and 2/3 onto both sides, right? To get rid of it from here, right? And then since you did that to the left side, you have to do it to the right side too. So now we do 4 and 2/3.
That's pretty much what I'm doing.
Yep. Just making sure, right? So in here we get, well, these two things cancel out, right? Those two things add up to 0. So now you're left with x alone here. So that's perfectly good. Now we just got to do 2 and 4/5 plus 4 and 2/3. Well, how do you do that, Joshua?
Make both denominators 15 and then multiply 3 on the left side, 5 on the right side.
Okay.
And add them together.
So you're saying, so do you want to do 2 plus 4 first and then do 4/5 plus 2/3 like that? So like this
4/5
is
plus 2/3 first.
okay. So reorder this around 4/5 plus 2/3 and then 2 plus 4. Okay. So then you said let's make these denominators 15, right? If you do not have the same denominators when you're trying to add fractions, you cannot add them, right? So then this becomes over 15, something over 15. What's
So
this?
it's 12 over 15 and 10 over 15. So
Right.
that's
The
22
idea.
over 15.
Yep. The idea is that this over here, you multiplied by 3, so you need to multiply your top by 3 as well. And over here, you multiplied by 5 on your bottom to get to 15.
It's 7
Yeah.
and 7 over 15, I think.
Right, because this is 22 over 15 plus 6, which is equal to 1, and 7 over 15 plus 6. So your final answer is x equals 7 and 7 over 15. All right, any questions from anyone on this problem here? Nice work. All right, let's take a look at part B then. Part B is very similar. We just have a couple more steps here. All right. Melody, what do we need to do here? So we want to solve for x. What's the first thing? What's the end goal here? Actually, what's the end goal?
Find out what x is.
Well, yeah, we do want to find out what x is, but how do we do that? Like, what do we need to get? Like, think about what we did in that last question, right? What did we want in that last question? Any ideas?
X on one side of only x on one side of the equal sign.
Yeah. On one side of the equation, on one side of the equal sign, you want x to be alone. So equal sign is right here. We have our left and our right sides. Is x on only one side of the equation right now?
Yes.
Which
But
side?
No. The right.
It's on the right side, and it's not on the left side, right? So what that means is we need to get rid of everything else on the right side that is not x. Does that make sense?
Yes.
But what can we do first to make things a little bit easier?
Evaluate the left side.
Yeah, we can go ahead and kind of simplify things, right? So what is 4 minus 5 and 1/5?
1/5.
1
and 1/5.
Positive or negative?
Negative.
Right, this is going to be negative 1 and 1/5, right? And then that's going to be equal to, and then what's that equal to over here?
2x plus 3 minus x plus 3 and 1/5.
Well, what can we do with all of that stuff? Can we do something similar to what we did on the left side?
Well, 2x is basically x plus x. So when you subtract x, it could just be like, because part of it's also subtracting. So we could simplify it by doing x plus 3 plus 3.5 and 3
Okay.
and 1/5.
Yeah, so instead of that, we can do x plus 3 and 1/5, right? I agree with you, because 2x minus x is just x, right? We learned about this back in the last section, right? We saw that things like, 3x plus 2x, hey, this is just 5x, right? If you have something like 2x minus x like this, that's just equal to x alone, right? This makes things easier because we don't need to worry about multiple different things. Yeah. Okay. And can we do something similar to 3 and 1/5?
Could turn that to 6 and 1/5.
Nice. Let's go ahead and do that. All right. And thanks, Melody. That's good enough here for now. Let's see how we can go from here to our answer. Allison, well, the one with a picture, I guess. Every single time, so one of them asks me which one. All right, the one with like a different picture. Yeah, Allison. Are you there? Okay. So what do we do from now to get our answer? From here. What do we do from here to get our answer of what x should be equal to? And then let's see. Matthew, get ready. You're gonna do 5.10.
Okay.
Yeah. So Allison's typing, so it's a little bit hard for you guys to see. So what you're saying is you want to do 6 and if you guys are answering questions through the chat, please send it to everyone so that everyone's able to see what you're typing instead of just me. Otherwise, no one's able to kind of follow, right? Okay. So you're saying 6 and 1/5 plus negative 1 and 1/5. So you're saying just go ahead and add this, and that should get you x alone. Is that right? Okay, so the problem with that is that doesn't work. And the reason why that doesn't work is because you want to get x alone, right? In order to get x alone, you need to get this 6 and 1/5 away. And in order to get this 6 and 1/5 away, what you need to do is you need to subtract it from both sides, right? Because in order to get rid of addition, you need to subtract, right? 1 minus 1 equals 0, right? If you're adding 1, you have to subtract 1 to get rid of it. So same idea, if you're adding 6 and 1/5, you need to subtract 6 and 1/5 to get rid of it. So you need to subtract 6 and 1/5. Does this part make sense? That is how you make this x alone. Does that make sense? Okay. So if you did this to the right side, what else do you need to do? You have to do it to the left side, right? You need to subtract 6 and 1/5 over here as well. Well, now what you actually have is negative 1 and 1/5 minus 6 and 1/5. That's a little bit different from what you said earlier, right? So what does this equal to? What is this equal to? What does this evaluate to? I should probably ask that instead. So what's the final answer here? 5? So are you telling me that negative, I don't know, like negative 1 minus 2 is equal to -1? Doesn't work that way, right? When you have two numbers, both negative, this is actually just the same thing as them being added together, but still negative, right? Like -1 minus 1 is equal to -2, right? You start at -1 and you go even more to the left. You need to be more negative, right? So you're basically just adding these two numbers and then making it negative. So what's that going to get you? Yeah, -7 and 2/5, right? So -7 and 2/5 is your answer here for x. So you're gonna need a little bit of practice with subtracting like working with negative numbers like that. All right, it's a little bit tricky, but you just have to remember how it goes. All right. Any questions here between parts A or B here from anyone? Any questions? All right, Matthew, let's hear what you got for part 5.10.
I can't see the entire question. It just cuts off a little bit.
Just think about this part, right? So we're just saying,
Okay.
you don't have to worry about parts A and B. I don't actually ever go off of the questions that are split out into parts that are all like part of the same question. I never really go off of that. But yeah, so in this question we have 31x equals 713, right? So in this question, what is being done to the x? What is happening to it?
Multiplication.
It's being multiplied by what number?
31.
Yeah. So how do you get rid of that? What do you need to do to get rid of that multiplying by 31?
Division?
Yeah, divide, right? So your opposites are multiplication and division. Those two are opposites. And then addition and subtraction are opposites. So you're being subtracted, you add. If you're adding, you subtract, right? If you're being multiplied, you divide, and if you're being divided, you multiply to get rid of stuff. Yeah. So in this case, your multiplication is what's happening. So you got to divide to get rid of it. So what do you divide on both sides?
Um.
So what number were we multiplying by again?
X.
Well, x by
31.
Yeah, so what do you got to get rid of? The 31, right? You want to get x alone. So how do you get rid of the 31? You said divide. So what number do you divide by?
31.
Exactly. That's exactly it. So at this point, you just divide by 31. But since you did that to the left side, what do you got to do? What do you got to do to the right?
You need to do the same exact thing.
Exact same thing. Yeah, that's it. So you got to divide by 31 over here. So this gives you x equals, well, what's 713 divided by 31?
$23.
Yep. And if you weren't sure about it, that's the way that you would do it. And that's pretty much about it. Any questions here, Matthew?
No, not really.
Lillian, do you have a question, or were you gonna try to answer something?
I was just gonna try and answer something.
Okay, you can do one of the questions from the next part. But before we move on, any questions from anyone else here? So the idea is always pretty simple, right? Just figure out first off what is happening to x, right? But if you ever see something like this where there's a bunch of things, first thing you want to do, simplify. Simplify the equation so that there's as few terms, as few things as possible, right? And then if you get it there, it's a little bit easier for you to work with, right? And then the next part is figure out what's happening to x. Are you adding onto x? Are you subtracting from x? Are you multiplying, dividing? What are you doing to x? If you know what's happening to x, you know what to undo. You know what to get rid of on the side with x, right? So that's what we want to do here. And that's exactly what we did here. All right, Lillian, sure. You can give 5.11 part A a shot. What's going on here?
So 5t equals -13. That means you have to find out what t is. You have to divide -13 by 5.
So why do you need to divide -13 by 5?
Because 5t is 5 times t.
So the way that we've been describing it, right, is what you want to do is you want to get rid of the 5. You want to get t alone, right? So to get t alone, you have to divide by 5 here. And since you did that on the left side, you got to do it on the right side too. And it's perfectly fine to think of it the way that you're thinking of it too. That's fine. That's fine. That's totally all right. It is correct. I'm not saying it's wrong. I'm not saying you shouldn't think that way. What I am saying is for the people that aren't familiar with that method, this is the method that we've been talking about. So I'm not telling you you have to do it this way. I'm not telling you your way is wrong. I'm not telling you your way is bad. I'm not saying any of that. What I am saying is I'm introducing it this way in case there's someone, in case anyone else is not familiar with your approach. Okay. All right. So now that we have this, we get t is equal to -13 over 5. Are we just done? Lillian, are we just done here? What was that?
No, we're not done.
Why not?
Because you still haven't divided.
Well, we did. 13 over 5 is a division. It's the fraction. Right? The fraction, like if you say, hey, what's 1 over 4? Well, 1 over 4 is 1 over 4. Right? It's the fraction form.
Well, I know 1 over 4 is 0.25.
Well, yeah, but those two numbers are the exact same thing. 0.25 and 1 over 4 are the exact same thing. They're both acceptable for the same number. Right? And the answer is yes, we are done. We don't need to keep going. We don't need to set. Yeah, you don't need to make this, like, oh, -2.6. You don't need to do that. You don't need to say that, hey, this is -2 3/5. You don't need to say it. They're all correct. They are all the exact same number. But we're right here. We're already done. That's it. T is equal to -13 over 5. Any questions here from anyone? So we've established that you can answer questions with a improper fraction. That's totally okay. You don't have to change it into a mixed number. That's totally by choice. That's all we're looking at here. All right, problem part B. 24 equals, oops, that's not what I wanted to do. 24 equals -75y. How do we solve for y here? Evan. How do we solve for y? So what's the goal? What do we want?
Simplify it.
Well, it's already as simple as it will go. 24 we can't simplify. 75 negative 75y we can't simplify. We cannot simplify either side here. So what's the end goal? What do we want at the very end? What have we wanted for the past few questions? What did we do every single time?
Divide.
Not all of them. Some of the questions up here we subtracted or we added. What was the goal for every single question? Do you remember?
To solve.
Wang Lina, help him out. What was the goal in every single question? What did we want at the very end? To find X, but not in every question was it X, right? Some of the questions it wasn't X. Some of the questions it was T. Some of the questions it was, first few questions, yeah, it was X, but in this question it's Y. But sure, we wanted to solve for Y. How do you do that? What did you need to be able to solve for Y? Well, can you be a little bit more specific? Wang Lina, can you be a little bit more specific here? Okay, how about Kai, I guess?
You isolate the variable.
Right. You want to get the Y alone. You want to get the variable alone on the one side, right? So in order to get this thing alone on the one side, we want to get this Y alone. Nothing else needs to be here. So currently, what is happening to Y? Evan, what is going on with this Y? What is happening here?
It's being multiplied by negative 75.
So what do you need to do to get rid of that negative 75?
Add 75.
Add 75? So you're telling me that if I add 75 here, right, this becomes just Y alone? Is that true?
Add 76?
You add 76 and it becomes Y alone?
No.
What's happening to Y? Is it being subtracted by 75 or is it being multiplied by negative 75?
Multiplied.
It's being multiplied by negative 75. What do you do to undo multiplication?
Divide.
So what should you be dividing by?
75.
Positive 75?
Negative.
Why negative 75?
Because it's being multiplied by negative 75.
Because it's the number that you're multiplying by. You divide by the number that you're being multiplied by to get rid of it. So you divide by negative 75, divide by negative 75. What do you get on your right side now, Evan?
Y.
And what do you get on the left side? Well, negative 24 over 75, right? That's exactly what we have here. But what do you need to do to this number? What do you need to do to this? Why do you need to simplify the fraction?
Because a fraction is just a division problem.
Well, how do you simplify this number here? We talked about this back in chapter 4 towards the end, around 4.6, 4.7. I want to say 4.6. What's going on here? How do you simplify it? Do you remember?
I don't think I fully remember.
You don't think you remember? Kai, help him out. How do we simplify this fraction here?
We can divide by a certain number.
What certain number are you talking about?
They're both divisible by 3.
Yeah, so if a fraction, if the numerator and denominator are both divisible by the same number, to simplify, you just divide by that same number. In this case, 24 and 75 are both divisible by 3. So this number becomes 24 over 3 is 8. So -8 over 75 over 3 is 25. So our answer is y is equal to -8 over 25. Does that make sense to you, Evan?
Yeah.
You need to remember how to simplify fractions, okay? Chapter, I want to say 4.6. Take a look at that. Just review that, all right? But this is simplifying a fraction. All right. So remember, the idea here is what you want to do is you want to get the variable alone. In order to get the variable alone, you have to undo what is being done to the problem, what is being done to the variable. So whatever it's being done, you have to undo that. If it's addition, you got to subtract away. If it's subtraction, you got to add. If it's multiplying, you got to divide. If you're dividing, you got to multiply. I cannot stress this enough. This is the one single most important idea in pre-algebra. The single most important thing. Because this thing you will need for basically the rest of your life in mathematics, when it comes to mathematics. All of the rest of your classes, you will need to know how to do this. If you do not know how to do this, you will struggle with every single problem, basically. That is how important this is. If you learn one thing from this class, this is what I want you to learn. How to solve these kind of questions, but this is not the hardest type yet. It is the next section that I want you to pay attention to, as well as the next section. This, if you learn like one chapter from this entire book, chapter 5 is the one. It is that important. Okay, let's take a look at part C and D. And let's start with Michael. Can you do part C here?
3 over 2.
So can you explain kind of step by step, how do you do that? Why'd you do it? You know, we have to hear all of that too, right?
7 times 3, because since it's already divided, you multiply it to reverse it.
Right, so u is currently being divided by 7. You want to get u alone. To get that alone, you got to multiply by 7. That's right. So you multiply by 7 here, which means you have to do it on the right side too. So you multiply by 7 here. So then this on the left side, what is that?
Y.
Well, it's the letter
Oh, wait,
U.
U.
But yeah, u. And then over here?
21 over 14, which
You-
simplifies down to 3 over 2.
Yeah, you can totally do it that way. Another thing you can do is remember what we said, 3 over 14 times 7 over 1 is the
yeah.
exact same thing as 7 over 14 times 3 over 1. And then this over here, you can simplify down to 1 over 2, right? You can always do that way. Or you can say, hey, this 7 over here and this 14, they're both divisible by 7. Let's get rid of that. This becomes a 1. This becomes a 2. Same thing. However, no matter what, at the end of the day, your answer's still the same. It's perfectly right. Yeah, logic's good. Answer's good. Everything's good. Just could have been a little bit simpler in the math that you actually did. Any questions here from anyone? If not, then part D, Lucy.
Yeah.
What's going on here?
Do you find a common denominator?
What's going on here? What is happening to your R? So first off, R is the variable of interest. It is what you want to find, right? What's the goal of this entire question? What do you want at the very end?
R is equal to 8 over 15.
Well, that's not what you want exactly. You don't want R to be equal to 8 over 15. You don't know if that's true, right? What you want is you want R alone, right? Every single time, we've always found U equals something, right? Y equals something, T equals something. We've always had variable alone on one side equal to number, right?
Yeah.
Okay, so at the what we want is we want R alone on the left side, right? Because right now, R is only on the left side. So we keep it on the left side, everything else goes away. So what is happening to R? If you knew what R was, how would you calculate it? Like what is being done to R in order?
It's negative 2r over 9, and you're trying to find r alone.
Yes, but no. So like what I'm saying is, okay, so let's say you had negative 2r over 9. If you knew r equals 1, how would you find the value of this? What's the first thing you would do? Or if you knew r equals 2, let's use 2 instead. If you knew r equals 2, what would you do first?
I would do negative 2 divided by 9.
You would do negative 2 divided by 9 first? You wouldn't do negative 2 times 2 first?
Oh wait, yeah, negative 2 times 2.
Okay, so what is happening to r first is negative 2 times r, right?
Yeah,
So you're multiplying by negative 2. That is what's happening first. What is happening second?
dividing by 9.
Okay. All right. This order is very important. This order of what is happening to r is extremely important. It will be even more important in the next few problems that we're going to take a look at next section. But right here, it's also important. Let me ask you, Lucy. When you work on, have you ever worked in like Microsoft Word, with PowerPoint, Excel, anything like that?
A little bit, yeah.
A little bit. Google Docs, maybe.
Yeah.
If you ever try, have you ever pressed Control Z?
I don't think so.
Do you know what this is though?
No.
Okay. Have you ever, do you know what the undo button is then?
Yes.
Okay. Have you ever pressed that?
Yes.
Okay. If you press the undo button, what does it undo first?
Your the last thing you typed down.
The last thing you did, right? So same idea here. Think of this as just pressing the undo button a bunch of times on this left side, right?
Mhm.
Think about it as pressing the undo button a ton of times. The first thing you undo is the last thing that happens. So
yeah.
when you undo this first, what do you need to undo first? Do you undo multiplying by 2 or do you undo division by 9?
Division by 9.
And how do you undo that?
You would do multiply negative 2.
You would multiply by negative 2 to undo division by 9?
I don't know.
You don't know?
No.
Sherman, help her out. How do we undo this division by 9? Lucy said that this is the first thing we got to undo. Well, how do we undo it?
Do you multiply by 9?
Yeah. Division, the opposite of division is multiplication. The opposite of multiplication is division, right? These two things are opposites. Addition and subtraction are opposites. Those two things are always opposite, right? So always think of it that way. Multiplication and division are opposites. Addition and subtraction are opposites. So in order to undo division by 9, we got to multiply by 9. Sound good, Lucy?
Yes.
All right, Shimon, let's go ahead. And thanks, Lucy. That's good from here. Let's go ahead and Shimon, let's have you take over the rest, right? So we got to multiply both sides by 9, right? Because if we multiply the left side by 9, we got to do it to the right. So what does that give us on the left side then?
Negative 18.
On the left side, Oh, okay, I see what you're saying. There's a really easy way to think about this, Shimon, right? We said we want to get rid of the division by 9, right?
Yeah.
So if we did things right, multiplying by 9 here should get rid of the division by 9. So you just ignore it and write everything else. So it should be just negative 2r. Make sense?
Yeah.
So what does the right side get us then?
I'm not sure.
You're not sure? How do we multiply fractions? We learned about multiplying fractions back in chapter 4.2. How do we do it?
You find a common denominator.
That's adding.
Oh, you multiply the numerator by the numerator and the denominator by the denominator.
Well, what's the denominator of 9?
1.
Okay, so we could go ahead and multiply straight through, or we could simplify it a little bit, right? Simplifying multiplication by fractions is really important. You do want to be familiar with this. The idea, the way that I do it is I think I look diagonally. Can I simplify anything here? Can I simplify anything directly upwards here? Well, I can simplify this here, right? What is there between a 15 and 9 that I can simplify?
They can both be divided by 3.
So do it. What do we get?
8 over 5 and 3 over 1.
So what's our answer then?
24 over 5, which
that
is
cannot
equal
be
to 4
simplified
and
at all.
4.
You don't have to do that. You do not need to change it into a mixed number. Okay? Do not change into mixed numbers unless you have to. And even then, do it at the very end. Okay. All right. Now we have undone this step. What else is there for us to undo? What else is there for us to undo? Other Allison, the one with the green box, I guess. What else do we need to undo here? We can take a look at our list. These were the 2 things we need to undo. We already got rid of this. What else is there?
-2.
So when you say -2, what is going on with the -2? Is it being added, subtracted, multiplied, divided? What's happening with it?
Multiplication.
Yeah. So how do you undo multiplication? What do you do to undo that?
Division.
Division. So what do we divide by?
-2.
Right. So we divide both sides by -2, right? Since you divided by -2 on the left, you got to do it to the right. So what does that give us here? R on the left side alone, right? Because -2r divided by -2, that gives us just r. So now we have r equals 24 over 5 divided by -2. That's the exact same thing as 24 over 5 times -1 over 2, or 1 over -2. Well, how do we do this then? Same idea as over here, right? Look up.
Simplify.
Look up. Is there anything we can simplify this way?
Yeah.
Yes. So there's something that is in common between 24 and 5, or 1 and 2.
Yeah.
What is there in common?
24 and 2. You can do 12 and 1.
So diagonally, yes. I was asking just up and down for now, but yeah. Diagonally, yes. Okay, what can we simplify here?
12 and 1.
Okay, so let's do 12 and 1 instead. And now we just multiply. Multiply straight across. What do you get?
-12 over 5.
So that is equal to r, and we are done here. R equals -12 over 5. Any questions here, Allison?
No.
Or from anyone else? Any questions on this problem here? That's it. So if you have multiple steps to a question, that idea of listing things out and then thinking about it, okay, we got to go through the opposite way. That's going to be really important. And we're going to see that in the next section a lot. But I'm not going to list this out every single time because it's not going to be something that you want to do. If you need to list this out every single time, sure, do it. But you should not have to do this every single time because this will take so much time. And time is important, right? If you use up a lot of time and doing a question, you're not going to have enough time to answer, all the questions in a test or something like that. You want to make use of your time well. So do not spend a bunch of time doing things like this. It's okay to do it for now while you're learning, But later on, when you have more experience with it, are able to do it a little bit more, you shouldn't have to do it every single time. But with that being said, let's go ahead and take a look at section 5.3, where we look at even more linear equations. All right, 5.12 through 5.14 to begin. So problem 5.12 right here, we have ourselves an equation. What is being done to our variable, and what do we need to do in order to undo everything here? All right, let's see, Caitlin.
First, I would do -9 to the left side and then -9 to the right side.
So why is that the first thing you do?
Because I would move the 9 and just have 8t, and then after I do 8t.
Okay, so the way that I've been explaining it, right? The way that I've talked about it is that the reason why the 9 is the first thing you do is because when you think about, okay, I know what t is, what happens to it first? Well, it gets multiplied by 8 first, and then step number 2, it gets added by 9. So the first thing you need to undo is the last thing that was done. So that's why the +9 is the first thing that gets undone. Okay, so if you undo the addition of 9, what do you get from here? What do you need to do to undo it? Subtract 9, right?
Yeah.
So what do you get on the left side?
65 minus 9, which equals to 56.
That's the right side. Okay. What happens on the left side then?
8t.
Sounds good to me. All right. What about the rest, Katie?
Then you do 8t divided by 8, and then since you're doing it to that side, you have to do that to the other side, and that would, the left side would become t, and the right side would become 7.
That's exactly it.
Equals 7.
That's exactly it. 100% it. Nice work, you two. So the reason why we need to divide by 8 is because currently we are multiplying by 8. So you got to undo that. To undo multiplication, you do division. I've said it at least 10 times by now, but I'm going to need to say it 10 times more. To undo multiplication, you divide by 8. So that's exactly what you do. And since you did it to the left side, you got to do it to the right side. But there are a couple times where you don't need to do it to both sides. When you do not change the number. If you multiply by 1, you do not change the number, so you do not need to do it to both sides. If you divide by 1, same thing. If you add or subtract 0, same thing. If you add 0 to one side, you don't need to do it to the other. If you subtract 0 from one side, you don't need to do it to the other because it doesn't change the number at all. Okay, let's take a look at 5.13 then. Right here, 7j minus 4 plus 3j equals 6 plus 2j minus 4j minus 8. That's a lot to look at. That is way too much to be looking at one time. Anna, what do we need to do first?
Well, first we have to have j on one side.
That is true. We do want to do that eventually. We do want to get rid of j from one side at some point. But there's something first that might make this easier. Is there anything that you can think of that would make this question a lot simpler than it is right now? There's a lot of things to be looking at.
We could add 7j and 3j. And on the other side, we could do 6 minus 8.
Okay.
And 2j minus 4j.
All right. So the idea is, let's split this up, right? We have our left and right sides, but the idea is, hey, we have j's, we have two things that both have j with them. Let's combine them into a single thing, right? So that we don't need to look at 3 things on the left and 4 things on the right. Let's look at 2 things on each side. So how do you do 7j plus 3j?
You just add the 7 and 3 and leave the j the same. So it would be 10j.
Right. And then the plus 4, does that happen? Does anything happen there?
No.
Oh, sorry, that's minus 4 actually.
Yeah.
But right.
It just stays the same.
Okay. So now what's on the right side then?
6 minus 8 would be -2.
Okay.
And plus -2 2j.
So minus 2j here. So now we have 10j minus 4 equals -2 minus 2j. All right. Thanks, Anna. That makes things a lot nicer for us to look at. All right, Chris, let's take it home. What do we need to do here? So Anna did mention, right? We need j on only a single side. So do you want to move the one on the right to the left, or do you want to move the one on the left to the right? It's your choice.
The one on the right to the left.
Yeah, doing that means that we have a positive j, right? Things that are pretty nice with when you're working with positive numbers. How do you move the one from the right to the left? What do you need to do?
You can add 2j.
Yeah, if you add 2j to both sides, it gets rid of it on the right, which essentially means it's been placed over on the left instead. Exactly. So what you're really doing here is you're getting rid of j on one side. You're not kind of moving it from one side to the other. You're getting rid of it on one side. So if we get rid of it on the right, we plus 2j, we plus 2j here, means that we have 12j minus 4 equals -2. What do we need to do now?
You can isolate the variable now, so
You want to get j alone, right? So how do you get j alone? What do you need to do first?
you can add 4 to the.
And why do you add 4 first? Why do you not divide by 12? Why do you not, I don't know, subtract 12? Why do you add 4?
Because you're not dividing by 12 first, because it's the one that's like closest to j. Like j is being multiplied by 12, and then it's being subtracted by 4.
Yeah, order of operations, right? First thing that happens to j is it gets multiplied. Second thing that happens to j is it gets subtracted by 4. So that's why that's the first thing you undo, right? Undo button undoes the last thing you did first. So that's the first thing you undo. Okay, so you add 4. So you got to do it to the right side as well, plus 4. So that gives us what?
2 on the right side and just 12j on the left side.
Now we have 12j equals 2. So what does that get us then? What do we need to do to undo this?
You can divide by 12.
Okay, and what's our final answer then?
j equals 1/6.
Any questions here from anyone? Nice work. I think that was like 3 of you, right? Nice work, 3 of you. 2 of you, 3 of you, something along that lines. Nice work. Can't remember at this point. All right, let's go ahead and take a look at 5.14 then. So 5.13 is very similar to what we're going to see in the next few problems. That's really about it here. Let's go ahead and jump into it. All right, 5.14. Okay, Jonathan, part A.
So you start off by adding 13 or -13 and 2/5 to -12 and 1/25.
So why is that the first thing you do? Can you kind of explain that real quick?
Because you said like you would start with the last thing you did.
Right, exactly. 8k, 8 is being multiplied first, then you are subtracting. So that's the first thing you undo, the subtraction. To undo that, you add 13 and 2/5 to both sides, and that's exactly it. So what is that going to get us then? On the left side, what do we have?
8k.
And then on the right side?
Well, can you write it out? Yeah. First you would make 13 and 2/5, 13 and 10/25. And then I would just I'd probably add -12 and 13.
Really? You wouldn't reorder it so that it becomes 13 and 10/25 minus 12 and 1/25?
I forgot about that.
Yeah, you can just reorder it, right? Make the 13 and 10/25 first, and then subtract 12 and 1/25 like that. That's a lot easier to look at, isn't it?
Mm-hmm.
What is that then?
That is it 1 and 9/25?
Yep. So now let's go ahead and make this an improper fraction. What is that going to be as an improper fraction?
34/25.
Exactly. Any questions so far from anyone? All right, so at this point we have 8k equals 34 over 25. Queena, take it home. What do we need to do here?
Now we need to, let me see. Now I need to do what equals k, right?
How do you get k alone?
I need to divide.
By?
What?
By what? Divide, yes. Divide by what?
Divide by I need to divide by the 8.
Okay, so we divide by 8 here. What do you need to do on the right side then?
Yeah, I need to divide it with the 34.
You need to divide 34 on the right side instead?
Well, I need to divide it with the 8 too.
Right, whatever you do on the left side, right? You divide it by 8. So you got to do it to the right side as well. So this on the right side, left side, what do we have now?
1.
1?
Yeah, and then the one you do for 30.
Are you sure it's not k?
Oh, well, yeah, it is k. And then it equals to 30, like, divide by 8, yeah, but like.
How do you divide by 8? How do you divide a fraction by 8?
You simplify it.
Or you multiply by 1 over 8. Dividing by a number is the exact same thing as multiplying by 1 over a number. And this idea here, this is what makes it a lot easier to divide a fraction by a number, okay? So this is the way that you want to think about it. Okay, what is this equal to? Is there any way?
Yeah, you can take out the 34 and the 8, and then you can make the 34 into a 4. 4. And then
Four?
make the 8.
Just a 4?
Yeah, and then the 8 turns into a 1.
So 34 divided by 8 is 4?
34 divided by 8 is 4. No,
32
it's not 4.
divided by 8 is 4.
Yeah, 32 divided by 8 is. I guess I just. I don't know what to do with it. I can't simplify or anything to make the number smaller or anything because I can't.
Is there any common factors between 34 and 8?
Yeah.
What number? They're both divisible by 2, right?
Yeah.
So get rid of the 2. What do you have now?
So I can put the 34 as a 2 and then
as a 2?
Well, 4 and then, no, like I mean like put
what is 34 divided by 2?
34 divided by 2 is sorry.
It's 17. What about 8 divided by 2?
8 divided by 2 is 4.
Yeah, you're gonna need to practice division a little bit more, right? So at this point, you just multiply across. There's no other factors that you can divide by. 17 times 1 is 17. 25 times 4 is 100. So you have k equals 17 over 100. Any questions here from anyone? So important that you recognize that at the very end, you have to multiply by 1 over 4, not divide by 1 over 4. And also you have to be very familiar with division, all right? That division, multiplication, addition, subtraction, those are things that you have to know in order to be able to do questions like this, all right? All right. Part B. What's the first thing we need to do here, Emily?
Me?
Yeah.
Like open up the parentheses by multiplying everything inside with the number outside.
Okay, so you're saying that we don't just say 4t minus 7. We have to say 4t minus 7 times 4. Is that right?
Yeah.
So why is that? What is the reason for that?
Because it's a parentheses, so it's supposed to be like a whole number, but we don't know what t is, so like we can only like multiply both of them by 4, or like
What is this
just
property
the
called?
distributive.
The distributive property. Right, right. Distributive property. So 4t minus 28. What is my right side then?
6t plus 9.
Okay, what's the first thing that we need to make sure that we have?
Plus 28.
Well,
And
I was gonna say, okay, sorry. What's the end goal? Let's start there.
isolate the variable.
Isolate the variable on, and then where do we want it?
The left side.
Sure, on the left side, but we want it on a single side, right?
Yeah.
So right now we have variables on both sides. What do we need to do first?
Get rid of the variable on one side.
Where do you want to get rid of it from?
The right side.
Okay, get rid of this from the right side. How do you do that?
Minus 6t on both sides.
What do we have?
Negative 2t minus 28 is equal to 9.
Okay, next step.
Plus 28 on both sides.
Right. The minus 28 is the next thing that is the last thing that happens. So it's the first thing you undo. So you have negative 2t is equal to
37.
What do you do now?
Divide negative 2 on both sides.
What's our answer? Emily, what's our answer?
T is equal to 18.5, I think.
Negative 37 over 2 is perfectly fine. You're doing extra work. You can answer with an improper fraction. That's perfectly fine.
Okay.
Negative 18.5 is also correct though. All right. Nice work. Any questions here from anyone? All right, Alex. Alex, you there?
Yeah.
Parsi.
I don't know.
You don't know? Okay, what's happening to your R? R is what you want to have alone, right? R is what your variable is here. You want that alone. So what's the first thing that happens to R? If you knew what R was, what's the first thing that happens? Any ideas?
No.
No ideas? Katie, what happens to R first here? Katie?
Oh, okay. I didn't know you were calling me.
You're good, you're good. What happens to R first?
You're trying to isolate the R.
Yeah, you want to get R alone, right?
Sometimes.
But what I'm saying here, like if you knew what R was, like if I said, okay, you want to find 2R minus 7 over 9, and you said, okay, R is equal to 2, what's the first thing you do? If you plugged in for R.
2 times 2.
So you multiply by 2 first, is that right?
Yeah.
Okay, what's the next thing you do?
Then you subtract what you got when you multiply 2 times 2.
So the next thing you do is
and
minus 7. And then the last thing?
And then you divide by 9.
Okay, so there's 3 steps here. If you knew what R was, the 3 steps are multiply by 2, subtract by 7, divide by 9. Okay, Alex, what's the first thing you undo then?
You would undo the times 2.
You undo the times 2 first? That's how an undo button works. It undoes the first thing you did.
No, I divide by 9.
So you undo the division by 9. Okay, how do you undo division by 9?
You multiply
By?
9.
So you multiply by 9 on both sides. Okay. What does that get me on the left side?
27.
27. It gets you 27 on the left side.
Wait, no.
It should just cancel out here. So you get 2r minus 7, right? That's what you're doing. You're undoing the division by 9. So if you don't divide by 9 anymore, it's just 2r minus 7. That's equal to 27 because you multiply by 9 on the right side as well. Next thing you undo is the subtraction by 7. So you add 7 to both sides. That gets you 2r, right? Because subtraction by 7 gets canceled, equals 34. Last thing you do is you divide by 2 on both sides. This gets you r is equal to 17, which is your final answer. Next week, well, not next week, but next time we meet is going to be next year. That's going to be all the time that we have here for today. Next time we're going to meet is going to be next year. We're going to pick up from here, I guess. Part D is where we're going to pick up from. And then we'll try to finish up the chapter next time around, all right? So this idea, this concept in chapter 5, this is really important. I want you all to do the practice problems here, okay? It's really, really important that you guys remember how to do all this. This is important, okay? So that's going to be it here for this week. This is the single most important chapter in this entire book. In fact, I may even go over a lot next time just because of how important it is. Now, with that being said, that's going to be it here for this year. That's going to be it here for this week. Queena, did you have a question?
Yeah, so is today the last class?
It's the last class of the year, yeah. Next semester is going to start up in January.
Yeah.
Okay.
Yeah. So yeah, if you guys have any other questions, feel free to ask. If not, then
Is
you guys are all free to
next
go.
year, if for class next year, are we like gonna like be doing this on like the same Zoom meeting we do every week?
Do you mean like the same ID and everything? I don't know about that, but should be the same time. It'll be the same time. That's all as far as I know, it'll be the same time. That's all I know.
And see you next time we meet.
All right, yeah, goodbye.
Next year. And I hope you have a great winter break.
Yeah, you too.
And I cannot wait. I hope you get a lot of presents under your Christmas tree from Santa.
I'm an adult. They don't give me that anymore. All right, goodbye.
Joking.
Yeah, next time around.